First three terms of a geometric sequence are given. So this one we could call A, and then it would be A times a common ratio, because that's what's going on with a geometric sequence. And then the third one would be AR squared. Don't actually need to go into loads of detail on this though. The key thing is to get R, you would take a term and divide by the previous term. So R is going to be 9 to the power of 7 minus 2k over 3 to the 4k minus 5. Now I can immediately see I've got powers of 3 in the other two, so I'm going to write 9 to the power of 7 minus 2k as 3 squared to the 7 minus 2k, and then that will become 14 minus 4k when I times the 2 through by the 7 minus 2k. So now I've got it in that form, I'm going to write R equal to 3, the power of 14 minus 4k over 3 to the 4k minus 5. But I can also get R by doing the third term divided by the second term. So then that will give me 3 to the 2k minus 2, I've expanded that bracket, over 3 to the 14 minus 4k. Again, I've used the other form that I've just written for the second term. Now you could deal with some division by subtracting the powers, but I feel like it's going to be easier if we just cross multiply. And then we're going to get 3 to the 14 minus 4k. Then we're squaring it. And that will equal 3 to the 2k minus 2 times 3 to the 4k minus 5. So when I square, I can just multiply that power through by 2. 28 minus 8k. On the right, I'm going to get 3 to the 6k minus 7. And because the base is the same, I can now equate the powers. For this to be equal, it must be that the powers are equal. So 28 minus 8k equals 6k minus 7. That means 14k equals 35. And if we divide through, we'll get k equals 5 over 2. Divide and then simplify. So that bit's sorted. It says, hence find the sum to infinity of the geometric sequence. So this is in the formula book as S infinity is A over 1 minus R. So we're looking for R to be between minus 1 and 1. So let's work out what R is. Actually, I might first of all work out what A is. It's going to be, right, 4 times 5 over 2 is actually 10. So it's going to be 10 minus 5. It's going to be 3 to the 5, which ends up being 243. So that is my first term. And then to get R, I'll put my k as 5 over 2 back into, let's put it back into this one. So I already know the denominator is going to be 3 to the 5 because that was the first term. And then at the top, I'm going to get 14 minus 10. I'm going to get 3 to the 4. So R is 1/3. Right, okay, this is going to converge. Brilliant. So then S infinity will be 243 over 1 minus 1/3, which ends up being 243 over 2/3. And we can times by 3, divide by 2, we get 729 over 2. And I think it's fine to leave it like that, but if we wrote it as a decimal, then it would be 364.5.